Welcome to our unit circle guide video. We will be discussing degrees, radians, cosine and sine coordinates, tangents, quadrantals, the relationship between special right triangles and the unit circle, and some tips and tricks to memorize a unit circle. First, we'll start off with degrees. For 30 degrees, use a 30, 60, 90 triangle to make a 30-degree tick mark on the circle. Make sure to have the angle of 30 degrees pointed towards the center, as shown in the video. For 45 degrees, use a 45, 45, 90 triangle to make a 45-degree tick mark. For 60 degrees, use the same 30, 60, 90 triangle, but use the angle of 60 degrees pointed towards the center of the circle. Keep in mind that you will need to flip the triangles over for certain angles. Side note, there's a difference of 15 degrees between the three angles in the quadrants, like 30 degrees to 45 degrees or 45 degrees to 60 degrees. There's also a difference of 30 degrees between an angle and a quadrantal. A quadrantal is 0 degree, or are 0 degrees, 90 degrees, 180 degrees, 270 degrees, 300 and 360 degrees. 0 and 360 degrees are in the same location. So the difference of 30 would be 0 to 30, or 60 to 90, or 330 to 360. If you don't have any special right triangles on hand, don't worry, a protractor would be just as good. To find radians, use the formula shown. If you have radians but you're trying to find degrees, use this formula here. Memorizing radians can be a little bit trickier, but there is a pattern that's constant. In the denominator, starting from the x-axis up in the first quadrant, it has a 6-4-3 pattern, as shown. In the second quadrant, this is true as well. As we go down to the third and fourth quadrant, it goes from the x-axis down. And in the second quadrant, the numerator is a little bit different. The numerator is 1 minus the denominator. So it would be 5 pi over 6, 3 pi over 4, 2 pi over 3. In the third quadrant, the numerator would be 1 plus the denominator. It would be 7 pi over 6, 5 pi over 4, 4 pi over 3. In the fourth quadrant, I just remember the numerator is 5, 7, 11. I personally don't have a way of remembering it. For the quadrantals, 0 degrees is 0 pi, 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and 260 degrees is 2 pi, which is the same location as 0 pi.
So, to find the coordinates of the unit circle, you're going to use cosine for the x value and sine for the y value. So using your right triangle, line the 30 degrees up with the origin, and use SOHCAHTOA to find the x and the y value. And because x is cosine, you're going to use the adjacent over the hypotenuse, and for the sine, you're going to use opposite over hypotenuse. So you get square root of 3 over 2 and 1/2. You're going to do the same thing for 45 degrees. Your cosine is square root of 2 over 2, and your sine is square root of 2 over 2. Then you do your 60 degrees. Your cosine, because it's adjacent over hypotenuse, is 1/2, and your sine is square root of 3 over 2. And to get your quadrantal, you treat the graph like a coordinate plane. So your first quadrantal at 0 degrees is 1, 0. And your quadrantal at 90 degrees is 0, 1. And because you treat the unit circle like a coordinate plane, anything in the second quadrant, your sign is positive and everything else is negative. So the saying you can use to remember this is all students take calculus. So in the first quadrant, everything is positive, all is positive. In the second quadrant, students, sign is positive. So you're going to do the same thing you did in the first quadrant with the second quadrant. So again, using your triangles, you line up the 60 degrees for 120 degrees, and you get negative 1/2 and the square root of 3 over 2. For 135 degrees, you get negative square root of 2 over 2 and square root of 2 over 2. For 150 degrees, you get negative square root of 3 over 2 and 1/2.
As far as the third quadrant, sine and cosine are both negative. At a 210-degree angle, cosine is negative square root 3 over 2, and sine is negative 1/2. At a 225-degree angle, cosine is negative square root 2 over 2, and sine is negative square root 2 over 2 as well. At a 240-degree angle, cosine is negative 1/2, and sine is negative square root 3 over 2. When the angle is at 270 degrees, cosine is 0 and sine is negative 1. Transitioning into the fourth quadrant, cosine is positive and sine is negative. At 300 degrees, cosine is 1/2 and sine is negative square root 3 over 2. At 315 degrees, cosine is square root 2 over 2 and sine is negative square root 2 over 2. At an angle of 330 degrees, cosine is square root of 3 over 2 and sine is negative 1/2. Finally, we reach a full rotation at 3.
Now we're on to tan. Your tan is sine over cosine. So for pi over 6, it's sine, which is 1/2, over cosine, which is root of 3 over 2, which simplifies to root of 3 over 3. You do this for all of your radians. So tan of pi over 4 is 1. Tan of pi over 3 is root of 3. For pi over 2, tan is undefined because you can't have 0 as your denominator. For the second quadrant, your cosines are negative, so all of your tangents will be negative. Tan of 2 pi over 3 is negative root of 3. Tan of 3 pi over 4 is negative 1. And tan for 5 pi over 6 is negative root of 3 over 3. Tan of pi is 0. Now for your third quadrant, both of your values, cosine and sine, are negative, so tangent turns out to be positive. Tan of 7 pi over 6 is root of 3 over 3. Tan of 5 pi over 4 is 1. And 4 pi over 3 is root of 3. Tan of 3 pi over 2 is undefined for the same reason that 0 cannot be the denominator. For the fourth quadrant, cosine is positive and sine is negative, so your tangent will be negative. Tan of 5 pi over 3 is negative root of 3. Tan of 7 pi over 4 is negative 1. Tan of 11 pi over 6 is negative root of 3 over 3. And tan of 2 pi is 0.